say, oh, mom.
All right. Really, Arjun, let's go.
Is there a school on St. Patrick's Day?
Yeah, because, we're not Irish. I mean, I am, but they... Yeah. Well, and it's my dog's birthday today. Like, God, they had the nerve to send me in. Arjun.
Start celebrating your dog like a cute little. Get a whole day event. 24 hours. Yes.
There are
Responsible.
Irish people that do that.
There are American people that do that.
Okay. This problem, when it says find radius of convergence, this is straight up saying do the ratio test. Tanya, what does it mean to do the ratio test?
The ratio test is like you do the A sub n plus 1 thing.
So the n plus 1 term over the nth term. Okay. Yep.
You have another way. It's like I did it, but I don't know if it's like the right way.
Okay.
But I would like do 1 over n root n times x over 3 to the n, and then you can just say x over 3 is the r value, and then do x over 3.
Okay. So I get what you just said, and for these process, they just like that pull the L'Hopital's crap out of the top and then the bottom, and then evaluate them individually. They want to see the process of doing a sub n plus 1 over a sub n. Like they want to see it all listed out. So yesterday, as we did it, and third period was like, can I just call this n to the 3 halves and just do n to the 3 halves here and n plus 1 to the 3 halves there? Sure. But x to the n plus 1, I'm splitting it up in advance. X to the n times x to the 1 is x to the n plus 1. Do we agree? And writing it this way means when I cross things out, it's cleaner, and I don't lose that x to the first, possibly. And down here, I changed 3 to the n times 3 to the first, pull them apart, so those 3 to the n's canceled. And then rewriting the stuff that I have left, I end up with x over 3, which, Josh, you were like, I know that's what's coming out of the thing, because I can see through these now, which if you can't, go you. And all this crap, which the way third period wanted to rewrite it, n to the 3 halves over n plus 1 to the 3 halves, which is fine. The powers are equal, so they're going to go to 1. So what comes out is x over 3. And again, grading these last year for the AP, they really, really, really wanted to see those jail bars on this ratio absolute value has to be less than 1. Then taking the jail bars off, negative and positive, and then multiply both sides by 3, and we get that interval. And then there's something else, which today is the something else. What are we looking at?
Testing for the endpoints.
Testing for the endpoints. That is today. So, there's a whole big pain in the butt thing to do to see if we need to do some square brackets or round brackets on those ends. So Radius of convergence, they're asking for the ratio test. And then we need to do something else. Okay, the last test that you guys need to learn for convergence is the A, alternating series test. And to use the alternating series test, it's kind of a pain. You need to just state the things that have to be true and then go, hey, these things are all true, so it's going to converge because I said so. That's all there is to it. Whereas P series, we just said, hey, that exponent is greater than 1, so it's going to converge by P series. This guy, alternating series, Mateo, what do you guess is one of the conditions that must be true to use alternating series test?
To use alternating series test, there has to be a -1 in the general term.
Okay. Not quite.
Like R has to be absolute value of R is not 1.
Has to be an alternative.
It has to
series.
Thank you. Yeah, the obvious one. It needs to alternate. And by alternate, the way they're forcing this to mean alternate, they're like, all right, we're going to declare why they've gone from A sub n to U sub n. I don't know, but they do. They're going to say, well, all these terms are positive, and the signs between them went plus, minus, which means that's what we meant by alternating. So, Mateo, I know what you meant, but specifically, they just want the signs to alternate. Positive, negative, positive, negative, positive, negative. Okay, and the second condition, I used to not even make a big deal of it. It was like, this has to be true, otherwise the third thing doesn't hold true. And then the AP exam did some mean piecewise function that ruined everything. So you need to have every term getting less than or equal to the term before. The or equals. So it's allowed to go 1, 1, 1, 1.5, 1.5, 1.5, or sorry, a half, a quarter, a seventh, a 17th. But they have to be getting smaller or staying the same. And then the last thing is, looks like that nth term test. The very, very last term at the end of time, the limit is n goes to infinity, that nth term has to be approaching 0. Yep.
For number 2, does it mean absolute value bars as well? Or?
These guys are all, as they declared them, these guys are all positives. Right?
Oh.
So they're all the same size or a little bit smaller.
So you just take absolute value of the next terms?
Sure. So if all 3 of these things are true, then by alternating series test, that thing's going to converge. The irritating thing is every time you want to use alternating series test, you need to tell me these 3 things apply. All right. So our first example, the classic harmonic series. Harmonic is 1 over n, by the way. And it's got that negative sign. Teo, is it alternating? Are the signs turning on and off?
Yes.
Yes. Willem, are the terms getting smaller?
Yes.
Marco, is the nth term approaching 0 as n goes to infinity?
Yes.
Yep. So, because the signs alternate, the terms are getting smaller as we go along. The nth term does eventually go to 0, which this is not conclusive as an nth term test. It's like, I don't know. But if all 3 of these things are true, then you say, oh, well, holy crap, this converges. Okay. And a couple days ago, we did this thing conditionally or absolute. And I said, if the absolute value of those things If the absolute value of it converges, then it's absolutely convergent. Is this absolutely convergent? Like if I made everything positive, does it converge still?
To one, right?
Okay. The example we did before was this.
No, it would go.
Yeah.
It's repeating.
It would converge 'cause the
This-
sign wouldn't alternate.
No, it will converge. Converges to two. Yeah.
Yes.
This one converges absolutely because did it matter that the negatives were on and off? The R value in this example was negative 1/2, which was the absolute value of it was less than 1. Well, shoot, if the absolute value is less than 1, the positive of it's not going to matter. Did this one, does the sign being negative matter? Yes, it does. So this one is conditional. Conditionally convergent. What was the condition? It had to alternate. If it didn't alternate, this is regular old P series, and we know that one diverges. If it's all, okay, Eleanor, if it was all positives,
Yeah.
then it's just 1/n. Does 1/n converge or diverge?
Diverges.
By
P
P
series, yeah, sorry.
So the absolute value is gonna like mess us up. So it'll only converge if this one condition of being alternating holds
Yeah.
true.
No, exactly.
Goodness, yes?
Wait, for the thing it says if both of the following conditions are met, does that mean like 2 or is it just
No,
all?
no, there's 3. I'd officially taken it off the thing and then I was like, oh. So there's supposed to be 3,
Okay.
all 3.
All 3 have to be met.
All 3 have to apply.
Okay.
The AT exam made a piecewise series for, hey, if all of the terms that are even, you get this, and all the ones that have an odd subscript, you get that. And then both of them decreased on their own, but as a series, it was not valid. They were jerks. They were contrived and, anyway. Okay. So, in the packet, this example. Find the radius of convergence, that means do the ratio test, so do that. Okay, so doing ratio test, I get, this will converge when the absolute value of x squared is less than 1. How do I get the jail bars off?
Negative and positive.
Negative and positive, but how do I now deal with that squared thing?
Can you take out the two?
Wouldn't it be negative x squared? Yeah, because the negative.
Okay.
numbers-
An absolute value of negative x
It would
squared
be
became positive.
Oh.
And for these, it's like, I don't know how to deal with it. As an inequality, I'm just gonna make them equals. When does x squared equal negative 1? It doesn't. Okay, when does x squared equal positive 1? Oh, the negative came back, so I get a plus or minus. So this is the same as that. So it looks like I just got rid of squared, but I actually did a process. No?
I'm confused where you canceled out 2n over 2n plus 2. Because wouldn't that just simplify to
At
n
n
over
goes to infinity, I have 2 times infinity over 2 times infinity plus 2. Does that plus 2 matter?
No.
It's 18 million over 18 million and 2. That's going to be a fraction, like a decimal that's 0.0000000.
Okay.
What?
Alright.
Like it could be so insignificant, it's basically
So no I.
in this class, no I. No imaginaries, we get to throw them out and say, poo to you. However, now comes the point of 9.5. You ready? Party. Woo. Okay, so I have endpoints. I have negative 1 and positive 1. Maybe I can actually put an equal sign on one of them theirs. So the process is testing them one at a time, like this. All right. So when x is negative 1, I'm actually going to plug in the x value.
What's the spiral?
At the Greek letter, yeah. So instead of x, I'm going to put in negative 1 for x and say, does that one specific instance actually work? But what I mean by actually work, well, now take this power series. It's not non-power series. It's just a string of numbers. Tail, negative 1 squared becomes positive 1. And 1 to infinity, it's an actually 1, not limit of stuff. 1 to infinity is just 1. So this stuff goes away, and I am left with this series of stuff, which is just a list of numbers. So it's negative 1/2 plus 1/4 minus 1/6 plus 1/8, and it keeps going. Does this converge or diverge?
Converge.
Why does it converge? Because it alternates.
And
What are the conditions?
u to the n plus 1 is less than or equal to
It alternates, the terms decrease,
and as it approaches infinity.
and the last term goes to 0. So all of that work is needed to just do this. Oh, it could have equaled 1. All of that. And you know what? We get to do it all over again. Yes, Utah.
Explain why the negative 1 to 2 and you just got rid of it on both sides.
Oh, because Teo said negative 1 to the second, negative 1 squared became positive 1. And this is not an indeterminate form because we said, maybe 1 to infinity might be e, which we proved. But this is actually 1. If I'm just multiplying by 1 an infinite number of times, it's still just 1. All right. What do you think I need to test here? The other endpoint. So when x is positive 1, is this going to be anything different?
Probably not.
Why probably not?
because
Said like a New Yorker, by the way. There's no B's in that word.
1 to the 2n and negative 1 to the 2n is all gonna be
Negative 1 to the 2 and positive 1 to the 2 and then raised to the n. Okay, so again, I get this thing and all these same terms apply. So I get an equal sign on that one. So it converges on square brackets, negative 1, to square brackets, positive 1. All of this work was just to say equals. Hey, or what? Okay. You good?
Yeah.
Little spasm there. Go ahead. Do the ratio test. We're going to do all the kinds of things. So what x value is going to like? Because you could pick any x value. Is I view it as how much extra granularity information you get from that next term.
Well, that's what I was thinking, it's just like, either I thought it wrong, or because there's X and it's equals.
So when I'm doing ratio tests, people are getting 0.
Yeah.
What does that mean?
It's a divergence.
And Taylor, what does it mean?
That it diverges.
They converge only in.
So,
Okay,
Oh,
or no, into
what x value, so this means I am multiplying effectively by 0 to get the next term. Effectively, not really, but kind of. So, does it matter what x value I choose? Like, adding more terms on, like, it didn't even matter the whole term. X itself was so unimportant. This converges for any x your little brain can think of, because when we get to it, you had to pick a number. You need to pick something, you can put your finger down on the number line. It could be way down at 18 million. So you need to pick some x. And eventually, infinity is going to catch up and leave it in the dust. So any x value. Do I have n's to test? No. So it's got an infinite radius, and it works for negative infinity to infinity. Okay? Part C. Try that one.
so because
Zero means converge.
I think it just, yeah, I think it converges because you multiply by infinity.
For the
It's like, it would just go.
But it's where it's only,
it's
it's accurate up
has
to
to
something.
get smaller.
Please go.
That doesn't mean that it's still.
Wait, what do you?
So we don't do limit as angostas.
So a ratio test.
You can still multiply by infinity, so would it be like a set,
Is there
set number?
Okay, what's the consensus? So doing the ratio test, I get infinity, n plus one, basically, times x plus one. If I was listing out the terms, I would get 1 plus 1 yeah. Is there any x value that this is going to converge to a number?
Yeah.
What?
Say negative one.
At the center. Do I need to test endpoints? No, like it's only going to work at the center. There are no endpoints to check. So here we had 3 different cases. We tested the endpoints and they both worked. The second one, we didn't have any ends, it was boundless. It worked everywhere. Any x value you conceive of, it would converge if you plug that in. Here's the third case. Only works at the center. Very, very specifically, only works right here. Got that sweet spot, works only here. Got to choose x equals the same.
So if they ask for a radius, would you say what?
The radius is 0.
Yeah.
It's this dot.
Yeah.
Okay. And the last one, of course, is going to be different from all of those. Guys, remember you need to keep limits on these ratio test things. Did anyone get an interval yet, or what comes out?
-4 is 2.
Arjun says -4 to -2.
Yeah.
Yep.
And again, I'm splitting it up so I can cancel things more easily. X plus 3 to the n plus 1. Doing x plus 3 to the n times x plus 3 to the 1. Writing it like that, I can cancel without maybe accidentally crossing something out. Keep the limit on until it's evaluated here. At infinity, that's basically comes to 1, so what comes out is x plus 3. And then to check what interval works, squish that absolute value bars between -1 and 1. Josh?
For limit n versus infinity, why can't you do like 2n, but like FOIL it out, like 2n plus 2, and cancel out the 2n? Oh, wait, I get it.
Because they don't cancel. They reduce at infinity because they don't cancel. 2n over 2n plus 2 does not cancel to become 1/2. Okay, so are we done?
No.
No. Hunter says no. Arjun says we have to test the endpoint. Okay, Hunter, which one should we test first?
-4.
-4? Okay. So plugging in to this thing that we started with, it's not any old X value. It's now test the one endpoint that Hunter chose. So the only thing I swapped out is X. So Marco, what happens to this?
This is the,
-4 plus 3.
-1.
And it's -1 to the n. So look, does this converge, diverge, or I need to do something funny?
You need to do something funny.
Like what? Like-
Can you take out the 1 over 2n? Because that goes to.
But it's a -1 to the n. It's not really just 1.
Right.
So does it converge by p series?
No.
No? Does it diverge by p series? Arjun, what would you say?
Probably would diverge.
By p series, we have a problem. Yes.
Does this one have to like make sure that meets the conditions?
There was a reason we just did alternating series test. 1, does this alternate? Yes. Are the terms getting smaller?
Yes.
Does the nth term go to 0?
Yes.
Yes. So alternating series test is strictly list the 3 conditions out. Yes, it alternates. Yes, each term got smaller and smaller as n went up. The nth term goes to 0. All 3 of these things need to be true. So yeah, converges by alternating series. All that work was so that I could put an equals on that -4. Yeah.
Could you say absolute value theorem that because it goes 1, like for the next one, one goes to what's called, then that one will also, like, no matter what.
Okay, careful. Let's see. Putting in the -2, I get 1 to the n. Does this alternate?
No.
No. So alternating series test is not going to work for this one on the right. So doesn't alternate. So looking at the series 1 over 2 times n, does that converge or diverge?
Converges
Why?
because 1 stays at 1 and the denominator grows. Also, like I said, absolute value. So you can link the absolute value to -1.
Nope. Nope. I can integrate this and I get 1/2 natural log of infinity. It's going to grow really slowly, but it's eventually going to go to infinity. This diverges by what test?
Alternating series.
No, you can't.
P-
The n
P series.
answer.
So P series is still a thing, but there is a specific case that if it's an alternating series, that add a little, take a little away, add a little, take a little away, add a little less, then subtract a little less, it will eventually converge. It had to alternate though. So Hunter, you're trying to argue the absolute versus conditional. So if you had to guess, would you say this is absolute convergence or conditional? One end worked, one end didn't. There must have been a condition involved to make this one work and that one not. This would be a conditional. So the summation of things, the conclusion of all this. The first one, both ends were included, it worked. There weren't any special conditions that had to apply. Either end, all good. Square brackets included. This one, pick any x you want. It's going to converge for everywhere. It's not really, doesn't apply to call it absolute or conditional. The third one also, it only work at a specific value. That would not be called conditional either, but the last one, it worked in one place, didn't in the other, mix and match. That one's gonna be a conditional. Is there a reason?
Absolutely not.
So 2x. Okay.
Can you just announce what the answer is?
7, or school starts at 8, me at 7, 124. Have you not seen that?
Just let it go. Okay, so. Guys, as for the questions on absolute and conditional converters, not a great explanation, but power series, so meaning things with X on it. If both ends are included or both ends are excluded, like -1 to 1, open brackets, or -1 to +1, close brackets, we're gonna call that absolute. But if there's a mix and match, like one was included and the other was not, call it conditional. So the stuff on the back page is just summarizing everything. And that is 9.5. Test is Tuesday. And I'm not sure that's a good answer. Tomorrow is to go over homework from any section, if you still have remaining questions from 9.4. And let's see, how much time do we have now?
5 minutes?
5 minutes?
I mean, wait,
Want me to get the
I understand it now. It's all good.
Okay. This was 9.4, so 9.5. This is different than last night's homework? So how would you start number 1? Ratio test? Okay.
Or wait, here,
Oh, yeah, it just goes to.
Nth term test?
So nth term test is when it goes to, it can tell you if it diverges, but it can't tell you.
Nth term test only tells you if it diverges, and as n goes to infinity, that goes to 0, so that doesn't work.
So ratio.
The ratio test? I think ratio test is gonna
take
give,
out the.
you can. It's gonna converge or diverge, that first one. Some of you said, take the constant out front. Okay, 5 times.
You can do that. Oh, yeah.
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 Is that converge or diverge? What did you say? Diverge, why?
Oh, I just looks like it's.
Diverge, why? I don't know.
That's a fair.
With confidence, yeah.
We can compare it to 1 over n, and then use p series such that converges because it's like above.
So doing limit comparison, because this doesn't quite fit the p series. Like I know that it's going to diverge by p series, but that +1 underneath ruins everything. Oh, okay. So, reminder of some stuff that did not go well in that quiz. By limit comparison, both functions approach infinity at the same rate. So wherever they're going together. Why did we pick 1 over n? Taylor, why did you say that?
Because it's marginally, it's very closely above it.
We're not doing direct comparison. Direct comparison is in
Oh, because if
actually.
you divide it, it goes to 1.
What do we know about 1 over n? Does it converge or diverge? Why does it diverge?
Because of pieces.
So we picked this function because we know what it does. And we know what it does by p-series. And in step 1 here, by limit comparison, which you suggest we do, they both do the same thing.
I feel like limit
So-
comparison's kind of stupid because you already have to know what the function's going to
Yes.
do in order to do it.
Yes. And when you get to college, they give you questions you don't know the answers to already because it's harder to see. Right here, we're just, training, doing push-ups so that we can do that abs of steel stuff later. Mateo?
I just said it both converge.
Because I wasn't picking. They both diverge. This one diverges, takes that one to hell with it. Woohoo! Roar! Rock on, Taylor series style. Okay, happiness and joy or something.